All right, the last section of this chapter, we're going to look at a couple other situations where you can set up proportions. All right, the first one, a line inside a triangle is parallel to one of the sides if and only if. Okay, so this is a biconditional statement. If and only if it divides the other sides proportionally. So what does this mean? So one way we could read this is, if a line inside a triangle is parallel to one of the sides, then it divides the other sides proportionally. The other way we could read it is, if a line inside the triangle divides the other sides proportionally, then it is parallel. So there's two situations here, so I'll map them both out. So the first way to read this, a line inside the triangle is parallel. So I'm going to put a line inside here. It's parallel to one of the sides. It doesn't matter which side you pick. So I'm going to have it be parallel to this side. So these are parallel. So if these are parallel, that means that this line is dividing this side and this side proportionally. So we're going to put point E and F on here. And what we could say is that AE over EC is going to be the same ratio as FB over FC. Okay, so the fraction I get from here to here is the same as here to here. Another ratio I could say would be AE over FB is the same as EC over FC. Okay, because AE and EC are correspond. Okay, they're related because they're on the same line together. AE and FB are related because they're across from each other, right? And same thing can go for FC. FC is related to FB because they're across from each other, and it's related to EC because they're on the same line together. Wait, did I write the AE to EC? I should have FC to F. AE, EC, EC, FC. Yeah, that works. Okay. All right. The other way to take it is, if there's a line in here, so I'll write a different way. If there's a line in here and I can see that it's creating some kind of a proportion. Okay, so maybe this is 5 and 3, and this is 10 and 6. Okay, so we got these proportions in here. And this is proportionally cut into pieces like this, okay? Because this reduces to 5/3. This is 5/3. Then that allows me to say that these are parallel. All right, another one. Parallel lines divide transversals proportionally. So if I've got parallel lines here, okay, they're going to split these transversals proportionally to each other. So what I could say is AB over FE is going to be the same as BC over ED. Okay, so that's another proportion that you can get from some geometric figures. Of course, we could do all the different things to this, so I could say AB over BC equals FE over ED. Okay, because I switched the means, and that's going to hold up too. So AB over BC, this piece over this piece will make the same fraction that this over this would. And I can reciprocate both of these also, so I can put FD on top of that and ED on top of that, so you can reciprocate both. Last one is an angle bisector. Bisects the opposite side in proportion to the sides. All right, so what that means is this angle bisector is going to split this side up, but it's going to do it in such a way that I could make a fraction out of this side with this, or this piece with this side, and have it be the same as this piece and this side. So here's the proportion. We could say dB, so this over BA, or AB, is the same as DC over AC. Or I could say BD over DC is going to be the same as AB over AC. Okay, so these pieces are related because they're both on this side of the angle bisector. These pieces are related. Or you can relate these pieces to each other because they're part of the same line, and these are related to each other because they're both sides. Alright, so let's look at some problems that'll be similar to what you'll be expected to do. Alright, find QR. So I'm looking for this thing. I've got these parallel lines in here, so I know that since this line is parallel to this side, it's going to split these two other sides proportionally. So I could put 4 over 6, okay, these two pieces, and that should equal the same as whatever the question mark is over 9. When cross multiply here, I'm going to get 36 equals 6 times something. So of course x is 6. Alright, find GH, which is this piece. These are all parallel because I can see that their corresponding angles are all congruent. So by the corresponding converse, I know that these are parallel. If I'm not given parallel, this proportion isn't going to hold true. The lines have to be parallel. So now I can say that 28 over 30 equals y over 25. Okay, let's reduce this. This could be rewritten as 14 over 15, just to make our math a little easier. Cross multiply, I'm going to get 15y equals 350. Divide by 15. That goes in there twice and leaves a 50, which would go in there 3 times. Just leave another 50, and I'm just going to get 3 repeating here. So 23 1/3. Okay, and that's what this piece would be. Here's the last one. So I've got an angle bisector, because these two angles are congruent. This is 18. Now that's the whole thing. I need to know what these pieces are. So I'm going to assign one of them a variable. I'm going to say this is x. And now I don't want to call this y, because then I'm going to have 2 variables in my proportion. I'm not going to be able to solve for them. Okay? So if I were to call this y, I could say that x over 8 equals y over 12. So this is unsolvable because I'd have 12x equals 8y. Okay, so I'm not going to call that y. But I know this is 18, the whole thing. This piece here is going to be whatever's left over after I take away x. It's 18 minus whatever x is. So that's going to go in my proportion. And now I can cross multiply like I usually do. So I get 12x equals 8 times 18 minus x. Distribute. And I'll get 144 minus 8x equals 12x. Add the 8 over. 20x equals 144. If I divide both these by 2, I'll get 10x equals 72. Divide by 10, which is pretty easy, and x is 7.2. Okay, so this is 7.2. I want to know what QR is, which is this. So I'm going to take 18 minus 7.2. We get 10.8. So QR is 10.8. All right, and those are the types of problems you'll be doing in this last section.